welcome to our very first day talking about chemistry. This is going to be page 200 in your notebook, and all today is about matter. So our question is, what is matter? And matter is anything that has mass and volume. Okay, so if the object that you're talking about has a mass that is in some version of grams, and it has some kind of volume, then it is going to be considered matter. A rock is matter, water is matter, air is matter, plasma is matter. All these things are matter because they have a mass and a volume. Okay, the next page we're talking about is that there are 4 different types of matter. There's atoms, there's elements, there's molecules, and there is compounds. Okay, an atom, when we're talking about an atom, we're talking about really the smallest piece of an element that retains the properties of its elements. It's always made out of electrons, protons, and neutrons. We show it usually as a circle. It looks like, I'm going to call it a balloon. Okay? In this picture, we're looking at 3 different atoms. You see those circles? Those circles have letters in them. Those letters are symbols. Those symbols tell you what type of atom it is. The one that is Cl, that's chlorine. The one that says Mg, that's called magnesium. And the other one that says Cl is chlorine also. Okay, now the cool thing is here that all you have to do to count the atoms is simply count the circles. So we have circle number 1, circle number 2, circle number 3. So we have 3 circles, which means we have 3 atoms. Okay, so when we're looking at these 3 atoms, you don't have to worry about them having different letters in them. When we're looking at atoms, we are just looking at the balloons, okay? So we have 3 atoms here. Let me write that 3 there. Okay, so let's go to the next one. Okay, so in this next slide, we are talking about elements. An element is a pure chemical substance consisting of a single type of atom. All the elements are found on the periodic table of elements. Currently, there is 118 elements that we know of. Basically, what you have to remember about elements is that an element is material that has the same number of protons and the same general number of neutrons. It's basically the same thing. It is a whole bunch of the same atoms together. Okay? Now, when we are looking at this, I'm going to show you, color in some of these atoms to show you which ones are the same atoms. So you see this one? This one is chlorine, and this one is chlorine. Okay, so those are the same element. Those are 2 atoms that are the same element. Now, we're going to change colors here. We're going to make the magnesiums green. Mg stands for magnesium. Carbon, we're going to make blue. Oops, that's green. I don't want it to be green. I want it to be blue. Okay, there it's blue. And then we're going to change oxygen. We're going to make it yellow. I guess that's orange. And then hydrogen, we're going to make black. Okay, So when we're talking about elements, what we need to do is figure out how many different colors we have. So we've got red is one, we've got green, we've got blue, we've got orange, and we've got black. So we have 5 different elements here. 10. We have 5 elements. But how many atoms do we have? If you remember, all we had to do was count the balloons. So we've got 1, 2, 3, 4, 5, 6, 7. So we have 7 atoms and 5 elements. Now, when we're talking about molecules, molecules is any combination of 2 or more atoms. Now, this is important that these are 2 or more atoms. This will come into being very important in the next few minutes. All right. A molecule can be the same element. Not all molecules are compounds. We're going to talk about compounds in just a minute. Okay, so let's count our atoms. We have 2 chlorines, you've got 1 magnesium, you've got 1 carbon, 1 oxygen, and 2 hydrogens. So again, we have 7 atoms. Elements, we've got chlorine, magnesium, carbon, oxygen, and hydrogen. We have 5 different elements. Now, molecules are any combination of 2 or more atoms. So, the magnesium and the 2 chlorines are a molecule. So, if there are 2 or more balloons, then that is its own molecule. And they join using these sticks. We're going to call them bonds. Okay, so in this situation, we have 3 molecules. It doesn't matter if they are hydrogen, or if they are oxygen or carbon. Just so there is a stick connecting 2 balloons, we are talking about a molecule. Okay, a compound is very slightly different than a molecule. All right, now a compound is any combination of 2 or more different elements. This is important. Do you remember a molecule was a combination of 2 or more atoms? A compound is 2 or more elements. So here's the deal. When you have a compound, when you're looking at a molecule, which is what this is right here, you must have different letters in here. Now, you can have the same letters, but just so they're joined with another balloon with a different set of letters, it's a compound. Okay, so this one is a compound, and this one is a compound, but this one has the same elements. They do not, it has 2 atoms, but both atoms are the same element, so it cannot be a compound. Okay, so again, how many atoms are here? 1, 2, 3, 4, 5, 6, 7 atoms total. There are 5 elements, just the same as there were last time. There are 3 molecules, but there are only 2 compounds because H2 is not a compound. Okay, the last piece that we have in this idea is what is a mixture. And a mixture is a material made up of 2 or more different substances which are mixed, but they have no consistency in them. If you're talking about something like water, if you have pure water, we're dealing with H2O, and every molecule is an H2O molecule. When we're talking about a mixture, we're talking about something like sand in water, peas and corn in a meal together, dogs and cats. They're two different things mixed together, but they are very inconsistent. In this first picture, we have green dots and we have pink dots. If we are looking at a single compound or a single element, you would only see one color dot. So this is not an element. When you're looking at compounds, remember compounds are always joined with a bond. The stick represents the bond. There is no bonds here. The same thing going with molecules. Molecules will have bonds, so this is not a molecule. But this is a mixture. We know it is a mixture because it is not got any consistency. You've got red ones and you've got green ones, and they're all over the place. On this one, you can see you've got blue atoms and you've got red atoms, and the blue atom and red atom have a stick in between them, a bond, and each area right here, each object is consistent. See, red, blue, red, blue, red, blue, red, blue. So because there are multiple colors, we know we are not dealing with elements. Because they're consistent, we know we're not dealing with a mixture. Now, the question is this a compound or is this a molecule? A compound is any mixture of two atoms chemically joined. Are there two atoms here? Yes. Are they chemically joined? Yes. A molecule is two different elements chemically joined. It infers that there are two different elements. There's a red element and there's a blue element, and they are bonded. So this is a compound and a molecule. You can have that. That is not a problem. This picture shows purple atoms, blue and red molecules or compounds, whatever you want to call it. So we are not talking about a single element. We cannot be talking about compounds because we've got purple atoms loose around here. So the only thing this could be is a mixture. We've got one type of atom. They're all consistent. They're all the same atoms. So we are talking about an element here. Okay. We've got bonds and everything. We have different materials. So this has to be mixtures. Here we've got yellow atoms, but these atoms are joined. So this is technically elements of whatever represents the yellow color, but this is also a compound. The reason we know this is not a molecule is because it is made of two of the same elements. Molecules have to be two different elements. We know it is not a mixture because they're all the same color. Okay, there are 118 elements, but in every element has a symbol. That symbol has a capital letter. It always starts with a capital letter. It may it may end with a lowercase letter. Aluminum, its symbol is Al. Bromine is Br. Calcium is Ca. Carbon is C. Gold is Au. Helium is He. Hydrogen is capital H. Nitrogen is capital N. One of the things that I want you to pay attention to is the first letter is always capitalized. but the second letter is always lowercase. The chemical symbol is a 1 or 2 letter symbol that represents each element. The first letter is always capitalized. When we're looking at a molecular formula or a chemical formula, this means the same thing. It's all the chemical symbols in a molecule, meaning it's got chemical bonds, put together. The subscript, which is this little number right here, represents the number of each element. So Na means sodium. This says that there are 2 sodium atoms. There is no, you see a capital letter here, that's sulfur. You see there's no letter here, that means there's 1 sulfur. O means oxygen. This subscript, this is called a subscript, says that it has 4 oxygens. So Na2SO4. When you've got a single atom here, you don't say numbers. By saying its name, you're assuming that there's 1. So here's the name of the compound, and here's the molecular formula. Starch is C6H10O5. Glucose is C12H22O11. Acetic acid or vinegar, C2H3O2. Ethyl alcohol is C2H6O. Okay, when we have chemical equations are 2 or more molecules in a reaction. When you are adding them, they turn into something different. Okay, there is a plus saying I'm going to take this chemical and I'm going to mix it with this chemical, and I'm going to create a reaction. This yield sign means that there was some kind of reaction, and it is going to make this molecule. And that's all we've got, folks.